Okay, so let's look at some past exam questions here. I've got from the 2018 exam 1 question 2, so that's early on, so it's meant to be a relatively straightforward question. The matrix product 420 times by 412.8 is equal to, first off, so let's look at this. This is a 1 by 3 and a 3 by 1. So if we times them together, yes, they match, and they would give you a 1 by 1. So clearly B is out already. Okay, so the other options, you can see we've got a 1 by 1 and then other versions of a multiplication. So where they haven't actually performed the multiplication, but just shown it in other versions. So let's double check. Let's see if that's right. So that's 4 times 4 plus 2 times 12 plus 0 times 8, so 16 plus 24. It's clearly not 144, is it? You can double check that on your calculator if you like. Let's do that to double check for you all. So I have 1 row, 3 columns, 4, 2, 0, multiplied by, and I've got 3 rows and 1 column. So 4 tab 12 tab 8, 40. So here you can see that actually, me doing it by hand was actually a bit quicker than on the calculator. I could prove pretty quickly that that would be 40. Okay, so now we're down to these 3 options. Okay, so what has happened here with these is that we've actually looked at these original matrices and basically taken out a common factor. So with this first one, I can say, well, a common factor with 4, 2 and 0 is 2, isn't it? So that's 2 times 2, 1 and 0. Because 2 times 2 give you 4, 2, 0. Yep. And then here, with this second matrix, I can look at that and go, okay, a common factor there. And actually, looking at the options here, there's a couple of different things I could take out. If I take out 4, which is a common factor, okay, that does work. 1, 3, 2. But then when we get to simplifying that, you can say, well, 2 times 4 is 8. And these don't match the options that are here, do they? So I know that they didn't take out 4 as a common factor. Okay. So let's have another look at what we can do. 2 is still the only common factor that makes sense for this one. for this other one, let's take out 2 as a common factor. So now I've got 2, 6, and 4. Okay, so 2 times 2 gives you 4, times by that matrix, times by that matrix. Okay, so that leaves us with option E. It couldn't have been option D because, yes, that bit works out. But then what about this part? It doesn't work back to, that matrix there. Doesn't make any sense. Option C, yes, that bit, no, none of it works out, does it? 4 times there, it just doesn't work out. If I took 2 out, I took 2 out from that one, yeah, they would work out. But if I took 2 out from there, still doesn't work, does it? So E is my only option. 68% of the state got E correct. 15% of the state answered B. And 10% answered D. Now, that is, I think, for question 2, slightly tricky, but it's an interesting one nonetheless, and that really focuses on, do you understand the multiplication process? Okay, so again from the 2018, well, that should say exam 2, shouldn't it? This one is question 1 from the from exam 2, from this module. A toll road. Now, a toll road is, like CityLink, you have to pay to go on it, okay? A toll road is divided into 3 sections, E, F, and G. The cost in dollars to drive one journey on each section is showing matrix C below. Okay, so that's one journey on each section, so one way. Okay, so what is the cost of one journey on section G? So that is $2.87. Write down the order of matrix C. 3 rows by 1 column. Now, part A, 99% of the state got that mark. Part B, 94% of the state got that mark. Okay, so question C. One day, Kim travels once on section E and twice on section G. His total toll cost for this day can be found by matrix product M times C. Write down matrix M. Okay, so we know what matrix C is. Matrix C is a 3 by 1. So matrix M must have 3 columns. Okay, must have 3 columns. What do we think? And what do we think? How many rows do we think it's have? Now we come down to total toll cost. Total toll cost. So really we're wanting to know how many journeys that they've made on here, don't we? So we're going to have that as one row. So on section E once, not at all on section F, and twice on section G. I know it's 3 3 columns because it has to be, because there were 3 rows here. Now I'm saying that there's 1 row because we're finding the total toll costs. So that this way, when we do the multiplication, this times by this, we'll get down to a nice 1 matrix of his total cost. 66% of the state got the mark there, and some students gave the correct numbers but in a column matrix. Now it couldn't be a column matrix because of course that would look like that and be 3 by 1, so of course couldn't do the multiplication. So okay, question 2 from 2018 exam 2. So the West Horn Council must prepare roads for expected population changes in each of 3 locations. We've got main town, villages and rural areas. The population of each of these locations in 2018 is shown as matrix P 2018 below. And here we've got it there. So population of main town 2,100, population of the villages is 1,800, population of the rural areas is 1,700. The expected annual change in population in each of the locations is shown in the table below. Okay, so main town is going to increase by 4%. Villages are going to decrease by 1%. Rural areas are going to decrease by 2%. Now, before we get to writing down the matrix, have a think about how do we represent a increase by 4%. Okay, we times something by 1.04, don't we? How do we represent a decrease of 1%? You can times it by 0.99. Do you remember this from recursion? So a decrease by 2%, we times it by 0.98. Okay, write down matrix P 2019, which shows the expected population each location in 2019. So, main town increases by 4%. So, increase by 4%, so 2100 times by 1.04. That's an increase of 4%. So 2184. Villages 1800 times by 0.99 because decreases. How about I put a decimal in there? 0.9. That's a bit better. 1782. And rural areas 1700 times by 0.98. Enter. 1666. And that was worth 1 mark. 62% of the state got that mark. The feedback is some students gave only 1 or 2 of the correct elements. Okay, the expected population in each of the 3 locations in 2019 can be determined from the matrix product. P 2019 is equal to F times by P 2018, where F is a diagonal matrix. What's a diagonal matrix again? Diagonal matrix is a matrix where there's only figures on that leading diagonal, and all the rest are 0. Okay, so it's giving you a clue there that F is a diagonal matrix. What else do we know about it? We know that P18 is a 3 by 1, so F must have 3 columns, and a diagonal matrix is a type of square matrix, so it must have 3 rows. And that's how also we're going to end up with that 3 by 1, which is P2019. So write down matrix F. What do we have to times this by to get this? Okay. By the way, this is exactly how it was shown on the exam paper with these spaces. No clues here. Now, keeping in mind that when we multiply the rows by the columns. Okay. So to get that one, that first one, have to multiply something to 2100 to get 2184. Times it by that. 1.0400. Why am I putting the 00 there? Because if you remember, we've got 2100 times by, I'll do it the proper way, 1.04 times by 2100 plus 0 times by 1800 plus 0 times by 1700. So that's why we'd only end up with our 2184. Okay, 0 here, 0.99, oops, yep, 99, and 0 there. Because we only want to, here we only want to really do anything to the second row, to that entry here. So that means that has to be 0, that has to be 0, that has to be our 0.99. 0.98. So again, I'll write this out. So 0 times by 2100 plus 0 times by 1800 plus 0.98 times by 1700. So again, you can see that these zeros, we're doing the multiplication, but because they're 0, you end up with 0. So effectively, we're only doing any calculations on that one that we need to. Now, we need to have all of this to make the matrix work, okay? To make it work properly. And that's now works. Okay, I'll pause that there and then we'll come back in part 3.